Hi, and welcome to this lesson on experimental design.
In this lesson, we will be focusing on measuring transpiration using a potometer. The outcomes for this lesson is to understand what transpiration is, identify the factors that affect transpiration including temperature, wind, light intensity, and humidity, and lastly, analyze how water and dissolved minerals are taken in through the root of the plant. If you can imagine the stem of a plant to be like a straw, then transpiration is effectively the process of water and dissolved minerals being absorbed into the root of the plant and sucked up the stem to the leaf, where water will escape from the stomata present at the bottom of the leaves and evaporate into the air. We will be reviewing the effect of sunlight on transpiration. I've added a link in the description below to another video which teaches you how to set up your own apparatus at home to test the various factors that affect transpiration. Right. Let's get started. Here's a basic overview of the process you'd need to undertake when designing a scientific experiment. Number 1. Identify the independent variable and how it will be manipulated. 2. Describe the characteristics of the dependent variable. 3. List the fixed variables. 4. Decide on a sample size and sampling method. Our chosen method is using the potometer, and your sample size is dependent on how many plants you'd like to test your hypothesis on. So if you wanted to do this experiment with a sunflower and a daisy, you'd need 2 or more of each flower, while as many of each as the amount of categories you'll be testing. 5. You would need to list any apparatus, equipment, or materials needed to conduct the experiment. And 6. Describe how the investigation will be carried out by means of a method. Remember to be as descriptive as possible, so if someone were to repeat your experiment and followed your method carefully, they would receive exactly the same results as you. Your method must be written in point form and in the third person, so don't use terms such as I, we, and you. In order to write our hypothesis, we need to understand what we are trying to investigate. We are specifically looking at how transpiration is affected by the varying amounts of light. We would need to make a prediction about how light would affect a plant's ability to transpire. Will it increase as the amount of light increases, or will it decrease as light increases? Your prediction will be based off previous research done into how transpiration is affected by light intensity. What is meant by transpiration rate? In this instance, it can be measured as the distance that water moved in a pipette or straw, and that would be in the unit you've used to measure, so centimeters or millimeters. This happens over a certain amount of time, so for example, an hour. Thus, the unit for the rate of transpiration could be millimeters per hour. Time to take a look at our variables. For the independent variable, we would need to answer the question, what did we change? The dependent variable can be found by identifying what we measured and which units we used to measure. The controlled or fixed variables are everything we kept constant in order to make the experiment as fair as possible. The key to correctly stating fixed or controlled variables is to be as specific as possible. So rather than just saying the plant, mention the type of plant, the height of the plant, the pH of the water, the temperature of the water, etc. A great experiment always includes a control. Why, you may ask? Because it helps us to compare and verify our results. It acts as a measuring stick to compare how the chosen variable reacts in its normal environment versus how we've manipulated a single property to achieve certain results. So if we wanted to know whether fertilizer has an effect on plant growth, I would need to set up an experiment testing varying amounts of fertilizer in the soil to monitor how growth would be affected. For this to be a true reflection, I would need to set up a control with no fertilizer to test whether fertilizer is in fact the cause of an increase or decrease in plant growth. Meaning that if the plant without fertilizer grows taller than those containing fertilizer, I may conclude that fertilizer has a negative effect on plant growth. Similarly, if the plant containing the most fertilizer grew the tallest, I may conclude that fertilizer has a positive effect on plant growth and that the amount of fertilizer in the soil is directly related to the height a plant will grow. These effects are discoverable from the testing group. When recording results, we use tables and graphs. They are graphical representations or summaries of all the data collected. When drawing a table, remember to include an underlined heading describing what is being recorded below. The column on the left is for recording the dependent variable and the one on the right for the independent variable. Make sure to include the unit of measurement for the dependent variable in brackets and remember to leave out the unit when recording your measurements below. When drawing a graph, there is a standard layout to be followed. First, you'll need an underlined heading describing what is being recorded below. Your dependent variable is labeled on the vertical axis with units in brackets, and the independent variable is labeled on the horizontal axis with categorical descriptions included. How do we decide which type of graph to use? The type of data you are collecting influences the type of graph that should be used to properly display your data. Line graphs are used to display data or information that changes continuously over time. Line graphs allow us to see overall trends, such as an increase or decrease in data over time. Bar graphs are used to compare facts. The bars provide a visual display for comparing quantities in different categories or groups. Bar graphs help us to see relationships quickly. However, bar graphs can be difficult to read accurately. A change in the scale of a bar graph may alter one's visual perception of the data. In your conclusion, you will reflect on your hypothesis. You usually say something along the lines of, "My hypothesis was proven correct" or incorrect, and then give a reason for your answer based on the evidence provided from your results. Reliability means that no matter how many times the experiment is repeated, using this method, we must yield the same results. Validity refers to whether the instruments we used measured accurately enough what needed to be measured for the dependent variable. If we look at these three bullseyes, we can see from the first one that if an archer gains unreliable and invalid results, then it means that he cannot aim to the target correctly. Thus, the method used isn't reliable and doesn't yield valid results. If we look at the middle bullseye, we can see that his aim may be valid, but his method must be reliable as he yields the same results. And lastly, the third bullseye shows results that are reliable and valid are those which achieve their aim and yield the same results when repeating the experiment. We can improve reliability by repeating the experiment, taking multiple measurements and using an average, or increasing the sample size. We can improve validity by ensuring that all factors or variables other than the independent variable are all fixed or controlled, except for that which we are testing. Note that there are multiple ways to set up your experiment to get to the same conclusion, so be creative. What's important is the thoroughness of your experiment's design as to whether it answers your aim. Now you can have the confidence to design your own experiments. Continuous effort, not strength or intelligence, is the key to unlocking your potential. A quote by Winston Churchill.